Alright guys, so the first part, I'm just going to quickly refresh how to find the components, how to draw the correct vector diagram, and from there using SOHCAHTOA to find the lengths of the component. Okay. So the way we start is this. Okay, so they tell you have a force vector that's 3 newtons. Your baseline is west. It goes 45 degrees north of that line. Okay, so the way this looks is this. Okay, so your baseline is west. You start off in the west direction, which is there. Now you're going to go 45 degrees north. So remember, Cartesian. So you have never eat soggy waffles. Okay, so in order to go north, you're going to go this direction, 45 degrees. Good. So now you can get to the same spot in this force vector by pushing some direction this way and then some direction straight up. Okay. Now these two, what we call this leg and this leg, are both the components of this vector. Okay. Now, if we're talking about SOHCAHTOA, this is our adjacent side, this is our opposite side, this is our hypotenuse. Now, going into trying to, so that's how we draw it, right? So here's your baseline west, you go 45 degrees north of that. From here, what you do is we're going to use SOHCAHTOA to find both the length of the adjacent side and the length of the opposite side. So here, if we want to use sine, if we want to find the opposite leg, we're going to use sine. So just making a list of our knowns and unknowns. Okay, we know our hypotenuse for this is 3 newtons. The other thing we know is that our theta, our angle, is 45 degrees. Okay, so from here, we're trying to find A and we're trying to find O. Okay, so AX, or this, we should call this force X and force Y. Okay, this is the X component, that's the Y component. Force Y. So A represents the X component, O represents, in this case, the Y component. Alright, so finding the opposite, what we're going to do is we have sine of theta is equal to the opposite over the hypotenuse. Now, two things you know theta and you know the hypotenuse. Okay, so remember, sine of theta is just a number, so the sine of 45 degrees will give you, okay, that's going to give you 0.707. Okay, now that equals the opposite over the hypotenuse. Hypotenuse in this case is 3 newtons. So to solve for the opposite in this case, you just multiply it by 3 to both sides, multiply it by 3 to both sides, and you get 2.12 newtons is equal to your opposite side. Now your opposite side reflects Fy. It's the Y component. It's whatever's going vertical. Okay. Good. Now to solve for, let me just make a little bit of space. To solve for the adjacent side, we're going to use cosine. So cosine of theta is equal to adjacent over hypotenuse. So same thing. Remember, cosine of a number, if you have that degree, it's just a number. And adjacent over hypotenuse, hypotenuse is 3. Cosine of 45, when you plug that into your calculator, you're going to get 0.707. That equals A divided by 3. Multiply 3 to both sides, multiply 3 to both sides, you get A is equal to 2.12. Now, one thing you'll notice is this. Okay. Well, before I talk about that, this corresponds to the X component. So both of these are the same magnitude. The reason being is the angle. The angle is 45 degrees, so you get a special case in this case where it's the 2 legs are equal to X. And the hypotenuse is X root 2. You'll learn this in geometry. You don't necessarily need to know this in physics. So if you have any questions, let me know. Send me an email. This is how you resolve 2 components using SOHCAHTOA, and also how you draw the specific vector and where that angle goes. Okay, thank you.